All right, let's continue on. And you probably already figured this out, but for you to totally understand this, I would strongly suggest that you read the chapter in the book and look at the examples. I mean, that's what we're doing now, and I'm trying to do it nice and slow. All right. And I'm going to go till about, I don't know, for about an hour, I suppose, or so, but that'll be it. There won't be like another break, and then we'll continue on. It doesn't make much sense to do that. All right, so maybe for even 45 minutes, somewhere around 11:15, 11:20, we'll see where we are at that time. All right, so as it says here, the process of creating an object from a class is called instantiation. So they show it on the next page here. Now, there's different ways of doing this, and it's also here they're going to mention something that hasn't been mentioned before. All right. Now, in both these cases that they show right here, they're using that second constructor. So they are passing it in a code, a description, and a price. A code, a description, and a price. You already know that if they were going to do one, let's make product, big P, sorry, product P0, we could just say equals new product. And if we did that, it would be the parameterless constructor, all right? They're just not showing that. So this will, regardless of how you set this up, this will call a constructor. If for some reason you do not have a constructor that expects a string, and a decimal, the program will fail right there. I don't even think that you can put that into a try-catch. It's just going to fail. All right, because it's going to look for a constructor, it won't find it. I don't know if I've never checked with the try-catch to see if there's something like that. I don't even know why you would do that. All right. In this case, they're using what's called an object initializer. Look at the difference. Product equal new product, just like before, but now you say code equals, description equals, price equals. It makes it a little easier to see exactly what goes with what. Not only that, if we did this, hopefully what I'm about to say makes sense to you. Let's just say that we had called this one right here. And we put in here 56.50M, and then CB15, and then Murox, etc. Does it make sense to you that that would fail? Because it's expecting it to be, again, it doesn't give a rat's butt about names, but it's looking for types. It's expecting string, string, decimal. So if you give a decimal string, string, it's going to fail. All right. So I'm going to back up because I'm trying not to miss any of the stuff that they put in here. All right. So as it says, the first example shows how you can create two instances, pretty much what we just talked about. The second one, as they mentioned there, uses the feature called object initializers. So you don't explicitly call the constructor. It still will do this, but you are filling it in yourself, for lack of better words. So if you do it like this, look on the screen if you would. See this line in blue here? If you do it like this, if you say product one equal new product, then it's assuming somewhere later in your code, you're going to do something similar to what's shown below that. So it's the name of the object dot the name of the property. Does that make sense? This is how you will always refer to it. Okay? Now, you may or may not remember this, but we've looked at something in here, for example, like this. Okay, if you were to put this in here, int x equal math.pow 2, 3. All right, then what it would do is it would take the number 2 and multiply it 2 times 2 times 2. So that's 2 to the third, 2 cubed. So it would figure out 8, and it would assign it to x. Does that make sense to everybody? Okay. The reason I'm bringing that up is this. Guess what? Math is a class. And you don't have to create a math object to be able to use it. It's basically what's referred to as a static class, which means you don't create objects of a static class. You just use it by saying the name of the class dot the name of the method. And the stuff is built into the language. I'm not going to show you, but I could go back to my program and I could type in math dot on a line and you'd see all the different stuff that's in there. And there's math.pow, there's square root, there's a bunch of trigonometric functions like sine and cosine and some other stuff. All right. Now, they mentioned here with these object initializers, it says assume a product doesn't have a constructor. All right. In this case, you would use the following code to do this. So what they're saying is, are you typically going to do it like this? It depends. That's a crummy answer. I hate when you ask, that's like asking a person a yes/no question and it depends. All right. What does that mean? Does that mean you don't know? All right. What they're saying here is it depends on the situation. Typically, no. But when you're doing things like working with link, which we'll talk about at the very end of the class, all right, because it won't make sense until then. Other than that, you don't use these object initializers very often. Okay? All right. Now it says at this point, it's important to realize that a class defines a reference type. That may make sense to you. That may make absolutely no sense to you. All right? When I do this, when I come in and type in this, int x equal 23. If I knew where it was in memory, so if I knew that somewhere at address 3500 there was 23, okay, that's a literal value, right? But if I sit there and create this, if I create that we just looked at for a product, and I go and look for that and I type in this, product P1 equals new product. I'm going to just give it the parameterless constructor. And I go in and look at 3000, guess what I see in here? Nothing except an address. And I go to that address to find where it lives. All right, and what I'm saying is we're used to stuff like this, where everything is literal. Now we're working with references. All right. There used to be a show on TV. It was called something like Treasure Island or Treasure Hunt or something like that. And people on that show, they would go, like on an adventure, and they'd find clues. And eventually, hopefully, they'd find the treasure. But usually they found a clue, and what that clue was a clue to another clue. All right? So it didn't have the actual treasure in there. It had some information to get to the treasure. That's kind of what they're talking about here. All right? And we've talked before, if you remember earlier chapter, we used the out parameter and we used the ref parameter. And we talked about the fact that when you pass something in and you change it with a ref or with an out, it's a permanent change. All right, and that's because it's a reference type. Since a class is a reference type, when you make changes to what's in a class, they're permanent changes. Again, I don't want to sit there and read their stuff. You can go and read that stuff yourselves, okay? All right. Now, this is actually pretty easy. So if you look up on the screen here, let's assume for a second, I'm going to create it and then I'm going to remove it right away. In fact, let me get rid of that button. I don't want that either. Or try to get rid of it. There we go. So let's assume that I wanted to create a new class. Okay? First of all, the thing to realize, I may have mentioned this before, I don't know. Classes can only have code in them. Classes cannot have GUI stuff. They can't have components. They can manipulate GUI components, but they can't have GUI components in them themselves. They're just code files. So if I wanted to come in here and in my card designer, if I wanted to create a new class, I could come in and right mouse click on the name of the project, not the solution, but the project, right mouse click and choose add. And notice that when I do that, I can go to new item, but if I go down to the very bottom and look at the second last thing, notice what's there, class. So I can do it either way. I can go to new item, and if I go to new item, the first thing that's there is class. And it'll automatically have a .cs file. And just like forms are form 1, form 2, form 3, classes are class 1, class 2, class 3. So if I wanted to take all this stuff that I'm working with my card and put it into its own class, I could come in here and type in, how about just greeting card? And now I got a new class. All right. And I could put stuff in there, and I could have this class actually talk with this class by giving it what's called a reference to that class. All right. So let's say that I put a bunch of stuff in here. I'm not going to put anything in here, but let's just pretend I did. And now I want to be able to use that in my card designer. You with me? I want to be able to use that in there. All right. So if I come in here and I right mouse click on here and I click add, and there's a bunch of stuff in here, but one of the things that's in here, if I go down far enough, is the word reference. See that? You see what I'm doing here? And if I choose reference, I showed you this before. You may or may not remember it, but that's when we went and grabbed a bunch of Visual Basic stuff and put it into our program. But there's also something up here. Look on the screen, please. It says project. And if I click project, well, I don't know why it wouldn't show me that, but you'll see it later, examples. What's going to happen in here is, what's going to show in there is the other class that we create. So it's going to show the greeting card. And that's how you can link stuff together. We're going to start doing that already probably tomorrow. All right. I think it's not linking because there's absolutely nothing in there right now. So I'm not worried about it. So that's how to add a class. Okay, you can do it either way. You can either right mouse click, choose new item, and boom, it's the first one, or you can right mouse click and go down to the very bottom and it'll show it there. There's no difference between doing those. As it says, when you do that, the namespace and the class blocks are automatically added to your class. All right, and that's actually an important concept because with what I just did here, notice namespace card designer, see that? All right, and if I go up to this, and I go to my form here, and I right mouse click and I view the code, namespace card designer. So it's smart enough to know that. There's another kind of file that you can add in here, because we'll see this later. You can right mouse click on here, and you can choose add and new item. But now if you choose in here, what is it? There's one for source file. Of course, I don't see it now. General text settings. But there's another way that you can do this too. We're going to see this at the end of the chapter. All right, so I'll hold off on it till then. All right. So how to code fields. It says you can create two kinds of fields: instance variables and static variables. Instance variables belong, each one of you has a height, a weight, a hair color, and an eye color. Those are static variables. They can change over time. Person changes their height, their weight. You probably don't change your eye color, but your hair color can change. Those are those are instance variables. But let's suppose for a second that each time, I think I've given you this example before, but let's suppose that each time I create a new person object, I want to add one to a person object counter. Are you with me? So if I create one for each one of you, I want that person object counter to be equal to 7. That would be a static variable. That is shared. So a static variable is shared by all instances. Okay? An instance variable is unique to each object. I can't think of any other way to say it to you than that. All right. It says when you declare a field, you should use an access modifier. This is the first time we've really dealt with access modifiers. We've usually just said static void or static whatever. If something is public, it's available in that class and in any other class. Anybody can use it. All right. Normally, you never make class variables public. You normally do not do that, especially instance variables. You don't make them public. Static ones, you could. All right. Almost always, your methods are public, whereas your variables are private. So almost always, your variables in a class will be private. So they're only able to be manipulated directly in the class itself by the public methods. You make the methods public so they can be used by your class and other classes, but you make the data that gets manipulated by them private. Now that's a generalization because you can have private methods. You can have public data. You normally don't have public data, but you can. Usually if people are writing code and they're writing a lot of public data, they don't know what the heck they're doing. All right. But there may be a reason to have private methods. Private methods are usually referred to as utility methods. So if I write a method to do something, but that method has to call another method to do its job, I might make that other method a private method. All right? Because it's a helper method, so to speak. Again, so private, it can only be used within the class that defines it. Public can be accessed by other classes. And there's even other ones. All right, we'll look at those in later chapters, but for now, public and private will suffice. You can also make something read-only. Now I'm going to jump back here quite a bit. Remember when we looked at this? If something has both a getter and a setter, that means it's readable and writable. Does that make sense? It means you can change it or you can grab it. If something has a get in there but no set, it's read only because you can't set it. And occasionally, you might have something that's got a set in there but not a get. It very rarely happens. That's something that's write only. All right. Now that I've told you that, now I get to confuse you maybe even more. Because you can, when you declare a field like this, you can declare it to be read only when you declare it. All right. And again, what does that mean? That means that if you do have the thing that we showed before, it'll have a getter but no setter. All right. So in virtually, it acts like a constant. So why wouldn't you just use a constant? Because you can say public read only int limit and not give it a value. With a constant, you must give it a value when you declare it. With a read only variable, you must give it a value before you use it. So if I had different class sizes, let's say I had 5 classes and they ranged from 10 to 50 people, and I wanted to be able to use in the same program, I could have a thing called class size that I could ask at the beginning how many people are in this class. All right. And make it read only, but just say public read only int class size semicolon, and then later give it a value. All right. As it says, a variable defined at the class level within a class. So these are fields. All right. Again, they get called different things in different languages. Typically, they're just called instance variables in Java. I've never heard the word fields used like that in Java. So every language is a little bit different, a little bit quirkier in the way they do this stuff. All right. And I've said this before. If you want a one-sentence definition of object-oriented programming. This isn't 100% true, but it's true most of the time. What object-oriented programming is about is it is using public methods to manipulate private data. That's not 100% true because I told you, you can have public data, but you never should. You can have private methods, but you rarely do. All right. So next one here says, this is the syntax for coding a property. Well, one of the things they're showing you in here, take a look on the screen. Remember I told you this before? This is the shortcut. I couldn't remember if it had a semicolon at the end or not. I guess it doesn't. But you can sit there and you can do, if this isn't doing anything special, all right, you can just write it as get set. Now they changed it a little bit in here. They've got code equal value, which is fine. But if it's just a getter and a setter, then you literally will put inside of here just a curly brace, get, and inside of the curly braces, get, semicolon, set. Okay? There's a read-only one, already mentioned that. Now, look at I've said this to you before, but I want to make sure you get it. So notice that the getter and the setter, right there, one that sets and one that gets, in both those cases, you're using the capital letter. You see that? If it is a getter, then it's on the right-hand side of an equal sign. If it's a setter, it's on the left-hand side of an equal sign. To make this even more confusing, some programming languages call both of these getters, rather than one being called a setter and one being called a getter. Java typically refers to the one that's the getter on the right. It typically calls this an accessor, which means you're accessing the variable. You're not changing it. When it's on the left like this, in Java, it typically calls it the mutator, because you're mutating or changing its value. But it just depends on the programming language you're talking about. All right? So here they call them get accessors and set accessors. All right. So coding methods. Well, we saw the one method that was in here. And if you look on the screen here, does it make sense to you when you look at this example right here? And you look at the examples above? Get displayed text is an overloaded method. In the first case, it's got a string passed in that's referred to as sep. In the second case, it doesn't have anything passed in. So that separator could be a blank space, it could be a tab, it could be a pipe sign, it could be a comma, it could be whatever you wanted it to be. But whatever you pass in as a separator, that's what's going to be between each one of your fields. All right. In the second case, you're not passing anything in, so it's automatically just going to put a comma and a space in between each one. All right. Now, you may have seen this before, you may not have, what I'm about to show you. You may have seen it and had absolutely no idea what the heck it meant. But when you get a method that's overloaded like this, if you take your mouse and you put it over that, it shows you, hey, there's two of these. And it says right now, it's expecting you're going to put in there the one with a string. If you click the down arrow there, it'll show you the other one that's blank. Does that make sense to everybody? Again, I think it'll make more sense as you start seeing this in action. But it's showing it's an overloaded method. Why is it doing that? Because it's IntelliSense and it lets you pick the one that you want to use. So to provide other classes with access to a method, you make it public. We already talked about that. To deny or prevent other classes from accessing a method, you declare it private. Again, almost always the only methods that are private are these utility methods that public methods need to do their thing. Not always, but that's normally the case. The name of the method combined with its parameters forms the method's signature. We've already talked about a signature. That's why you're able to overload these methods. So when you create two or more methods with the same name but different signatures or parameter lists, they're overloaded. When you type the name of an overloaded method and type in the left paren, the IntelliSense kicks in, like I just showed you right there. All right. How to code constructors. If you haven't noticed, they're breaking this thing down. They've had big sections in here. They had one that was on properties. They had one that was on methods. They had some when they're talking about access modifiers, public, private, etc. Now they're talking just about constructors. So again, all I can do is supplement the stuff that comes in this book. I cannot replace it. I'm definitely not that good. All right. When you create a constructor, we look on the next page here, look on the screen. You may have noticed this before, you may not have. Constructors are public. Constructors cannot have a return type. And a constructor must be the same exact name as the class name. So since the name of the class is product, the name of the constructor is product. The good news is when we get to Java, it's exactly the same. All right. So if you try to come in here and say public void product, for example, you get an error message. Public int product, whatever. So this is typically referred to as a parameterless constructor. All it has is the open and close parens. I've read books where they call this, for example, since there's just 3 parameters and you're expecting all 3, that's a fully parameterized constructor. Some books will call it that. Some books don't give that stuff any name. It just depends on the book you're reading. Now, it says here, in some cases, a class might not be defined for any constructors. For example, you forgot to code a constructor. And again, if you don't, that's when that default one is coded for you. The one with paren, and nothing in it. Okay? Let's see. This is important. Look on the screen, please, at this thing in blue, which may make no sense, but I want to say it to you anyway. If I come in and create my own constructor, so if I come in and do this, if I make this one right here, then if I want there to be this one, then I have to create it. So if I create my own custom constructor, and I want there to also be a parameterless constructor, then I have to create that. If I don't create my own, I don't even have to create a parameterless one. One will be created for me that will set every one of my variables to their default values. All right? These are those default values. 0 for any numeric type, false for Boolean, null for a char, null, you can have, a class can contain a class. You might look at it, wait, a class can contain, what the hell does that mean? Let's say that I created a class for a clock. And I said that that clock had hours and minutes and seconds, was able to set itself, etc. Got all that? Now I want to create a new class. And I want to call it alarm clock. Well, isn't an alarm clock a type of clock? So I might make clock part of an alarm clock. All right, there's words for all that stuff. I don't want to get into that right now because it can get confusing. Right. All right, again, the next thing is on how to code static members. And static members, again, like I showed you that math.pow before, static members are called directly by using the name of the class, not the name of an object. That's important enough to say it again. Static members, whether they're methods, variables, whatever, they're called using the name of the class and not the name of the object. So they're shared. And I gave you that example. If we were going to have a person counter, if I didn't make person counter static and I made 7 of you, I wouldn't have one counter with a value of 7. I'd have 7 counters, each with a value of 1. So if you've got something you want all classes to share, you make it static. As it says, to create a static member, you include the static keyword. Now, hopefully what makes sense now, all right, remember when we were working on consoles, how whenever we created any variable outside of main, like if we created something up above, we had to use the word static because there was only one of them that was shared by the whole program. That's why it was static. And when we created methods, there was only one of them in our console apps that were shared by, no matter what we had in there. And that's why they were static. So when you look in here, now notice what they have. You can make an entire class static. So this is a class, it says, that contains static members. It's got a title. All right. And why would you do that? Because what they're doing is they're creating a generic error class right here that we want all errors to be able to share. And the only error that we're going to show is it's going to be just called entry error. And you might think, well, you'd never use that. You'd be surprised. If I'm writing a program that's a very complex program that uses databases and other stuff, and something goes wrong, I don't want to provide information to an end user or maybe a hacker. I want to say something like entry error. And if they're like, well, geez, what happened? You figure it out. Or you contact the help desk. That's what they're there for. All right. But you notice that everything, the name of the class, the name of the methods, all right, they're all the word static. So as it says, a static member is a field or a property or a method or a class, as we saw, that can be accessed without creating an instance of the class. You don't have to, when you declare an actual constant, if you remember when we did the word const in our programs, whether it was a console program or a GUI program, you don't use the word static because static is inferred. All right. Constants, there are only one of them. It's constant. It wouldn't make sense to have more than one. Again, if a class only contains static members, you can use the static keyword class to make it a static class. C# 2015 provides a new directive that lets you refer to static members of a type without naming the type. Well, it used to be you had to use the word this dot like I showed you before. Now you can, or you can leave it off. All right. And I'm recommending that you use it just so you can tell exactly what you're doing. All right. You may agree with that. You may not agree with that. All right. All right, let's go through this section, which is about the next 7 or 8 pages, and no matter what the time is then, we're finished with today. So this, as it says, this is a product maintenance application. So let's look at it. This is what it does. So if this is right here, this is a list box, which shows all the products we currently have defined. We currently have defined for our program. If you click the Add Product button, it brings up this form. And when you fill it out, if you click Save, it goes in here. So if what we're showing right here, if we click Save, we'd have another one in here that would have CS15, and then it would have 5650 and Muroc C# 2015. All right. For the delete button that you see in there, the delete product, you have to highlight a product, then click delete product. And the system will come up then, and it will say, are you sure you want to delete this product? Does all that make sense? All right. What we're starting to get into is what's referred to as a CRUD application. CRUD, C-R-U-D. CRUD means create. That's add. R means read, which is this. We don't have update capability, but we could add that. Where if you clicked update, if I highlighted, let's say that I spelled SQL server here wrong. Let's say that I put in SQL sever. Then I could click on that, click a delete button, and it would bring it up like this where I could change it. And D is for delete. Now, notice they're starting to use this tag property for the first time. So again, I've said this to you, but I want to show it to you. And that is, if I come back here, and I'll grab this. Here's my list box. And you'll notice if I go down, there's the tag property. If I go into my picture box and I go down, there is a tag property. If I go into the text box and I go down, there's the tag. Check boxes, there's the tag. Labels, there's the tag. So all controls have a tag property. We've never used it, but it's something that's available. Why is that important? Because it is possible with the tag property to be able to put in information that you only want to show at a certain time. All right. So what is it showing here? It's letting us know that this field right here, TXT code, is linked to this class property. This field to this class property, this field to this class property. Can you write this program without using this? Hell, you've done it the entire semester, so I guess so. But it can be used to provide additional information to the program. All right. So as it says, this product maintenance application retrieves information, in this case, from a file. All right. And later, it'll grab it from a list box. I'm sorry, from a database, rather. It displays it in a list box, and it lets you add or delete. Again, it's the CRD of CRUD. There's no update in this one. So if you put in something wrong, you have to remove it and put it back in again. Okay. And I explained to you how to add and how to delete a product. And as it says, the tag properties are set, so the validator class, so it's going to validate stuff, can display meaningful messages. What the hell does that mean? Well, I want to be able to write one validation routine, and I want it to be able to say it's a bad code, or it's a bad description, or it's a bad price. All I want is a generic error, but I want to only write one routine. And I want it to be able to handle 3 different cases, 2 of which are both strings, 1 which is not a string. So I'm using the tag to hold the name of those fields. All right. Again, there's other ways it could be done as well. All right. So this product maintenance application, as it says, it's going to use several classes, 3 of them. Okay. The product class is used to represent a single product. So look on the screen, please. Does it make sense? That's representing the product class. Because each product has its own code, its own description, and its own price. All right. The product DB class handles the I/O processing for the file, and the validator does the validation. Well, it's not exactly, but this is kind of like the one, the product DB class. All right, we're not working with a database yet, but this is basically showing the results of everything you've got. We're going to do something more similar to this as we start. Okay. All right. So they explain each one, but let's take a look at the code. The product class is what we've already seen. I'm not going to go over that again. They don't show the code because they've already shown it to you. It's got the 3 properties: code, description, and price. Code and description are strings. Price is a decimal. It's got the 1 method, the get display, which you can pass in a separator. It's got the 2 constructors, the parameterless constructor and the fully parameterized constructor. All right. Then we've got these 2 things. All right. Now, what we're going to be moving into is a way, I'm not saying we're never going to use arrays, but we're going to move away from using arrays and moving into using lists. The reason for that is, think about this example right here. Hopefully you agree with what I'm about to say. Over time, the number of books that are in there is going to change. You're going to add books. Books will become outdated and you might get rid of them, especially in this field. All right. You might have all sorts of new books, etc. Well, with an array, I could make an array and say that it holds 1,000 books and then fill it up, a little bit at a time. But if I've only got 4 books, I'm wasting 996 storage locations. That's kind of stupid. But if instead of doing that, if I create a list, remember that by default, a list has 16. And as soon as I fill it, it doubles. And as soon as I fill that, it doubles again. So I can dynamically add and remove things as the program's running. I can't do that with an array. I can do that with a list. All right. So that's why it says here, it begins by declaring a class variable named products of the list type. All right. Next, in the load event, okay, as it says, it goes out and it finds everything that we have and it fills up that list box with those products. All right. And it uses a for each loop to do this. And again, if you click the add button, it's going to create a new product. So as soon as you fill that stuff up. Now, one thing they're not going to do a lot of in here, but we're going to do more of it, is technically, I'm asking you this question. You should actually understand this too. Okay, this thing comes up right here. This form. I'm asking, can somebody tell me? I put nothing in any of these and I click save. What's going to happen? No. Isn't it going to call the parameter list constructor? It's going to make a new product for me, and that new product will not have a code, will not have a description, and will have a price of 0. That's correct. You probably don't want to allow that to happen, because what if you do it again later? Now you've got 2 products, and how can you tell those 2 apart? Do you understand what I'm saying? You'd have 2 products. So what we can do in there is we can add code. Guess what? You know how to do this, where you use try catch and if statements, and you make sure that if they put nothing in for a product code, okay, that you don't accept it. Not only that, what if the product code, if you look in here at these products, they all have what? Well, this one has got 3 numbers or 3 letters. This has got 2 letters. This has got etc. But we can even set it up so maybe it has to start with 2 letters. We can do that if we want to. All right. That's all validation. Description. Maybe we don't have a description yet, but we should at least have a name. And you want a price to go in there as 0. The reason that you typically don't want a price to go in there as 0 is if somebody forgets to change it and add the right price, and now somebody orders 100 of them and you send them, how much should they pay for it? That would be nothing. All right. That's why I said this is not probably going to make a boatload of sense unless you go back and read this. And even then, it doesn't. There's books that you can buy just on object-oriented programming. All right, one of my favorite titles, maybe you'll laugh, maybe you won't, but remember seeing it at the library, was called The Poop on Oop. And it was basically they tried to show everything. There's stuff online that you can go and look at for object orientation. Most higher level programming languages offer some type of object-oriented capability. All right. So when we come in here, this is our list of products. See that? That's going to hold all of our products. We make it null right there, so it does have an initial value. There's nothing in it. It's null. It's devoid of any value. All right. Then in our form load event. Notice what we're doing in here. We're calling get products. Well, where the hell is that? There's no get products here. There's no get products there. There's no get products. Where's it going to get products from? It's getting it from the other class that they've created that they'll show in a page or two. All right. There's the validation. In fact, the get product one, I think they don't even show it. They don't even show it, I believe, until like chapter 22. So what I'm going to do is I'm going to stop it right here. We're going to pick it back up by going over this code that you see starting on 386. We're going to start on that tomorrow morning, and we're going to go through the end of the chapter. Once we get through the end of the chapter, we're going to go through a simple example, starting with a console app of doing this ourselves. All right?